Hi there, mathematicians. Let's take a look at effects of changing dimensions, section 11.4. Our objectives are to describe the effects of non-proportional dimension changes, along with describing the effects of proportional dimension changes. And our essential question, how does changing one or more dimensions of a rectangle affect its perimeter and area? All right, let's take a look at changing dimensions non-proportionally. So when you change one or more dimensions of a figure, you also change the perimeter and the area. So let's take a look at this first example, a right triangle with base 3 and a height of 4. And let's just double one dimension, the height. And we want to compare before and after. So let's do a quick moment to set up a chart similar to what you see here. All right, so our calculations for perimeter with dimensions 3 and 4 would be 12 centimeters. And 3 and 4, to help you figure out your hypotenuse, the missing length. Remember, this is a special right triangle, so 3, 4, and then the hypotenuse must be 5. But if you don't remember your special right, Pythagorean triples, then you can use Pythagorean theorem. So 3 squared, which is 9, 4 squared, which is 16, added is 25, square root of 25 is 5. So 5 plus 4 plus 3 results in 12 centimeters. Then for your area, it's half the base times height, so half of 3 times 4, which is 6 square centimeters. So now let's take a look at changing one dimension only. And we are going to double the height. So now the height is 8. Base did not change. Have to use Pythagorean theorem again. So I square the 3, square the 8. These are not perfect triples, Pythagorean triples, so we can't just use that knowledge. We have to actually use Pythagorean theorem here. So 9 plus 64 results in 73. And square root of 73 is as simple as it gets, so you'll leave it alone. The 3 plus 8 out in front, stay out in front as 11. By typing that in your calculator for a quick approximate value, you get 19.544 for the perimeter. And then your calculations for area result in 12 square centimeters. So now let's compare. So it looks like doubling the height increases the perimeter by about 7.54 centimeters and increases the area by a factor of, if you divide the new by the original, it's a scale factor of 2. So that scale factor 2 matches what we applied to the height only. All right, so let's change the length by 1/3. Multiply the length by 1/3. So now we're dealing with a fraction. So before the change, do all your calculations. So the length is 12 feet and the width is 5 feet. I had to take a quick moment to sketch in the rectangle that I completely forgot to include on my video here. So we're dealing with a rectangle. We're multiplying the length by 1/3. Here we go. All right, the length is 12 feet. The width is 5 feet. So the perimeter we know as the formula for a rectangle is twice the length plus twice the width. So plug in your 12 and your 5, work out the math. So our perimeter is 34 feet. For area, length times width, so 12 times 5, 60 square feet. So this is before we change anything. So now let's take a look at after the change. So 1/3 of the length. That means you're going to multiply 12 by 1/3, or in other words, divide 12 by 3, resulting in a length of 4 feet now. Didn't change the width. Remember, we're only changing one dimension just to get a feel for how it affects the perimeter. So we take a look at the perimeter, and we get now a perimeter of 18 feet. And for area, we get an area of 20 square feet. So compare the two perimeters, compare the two areas. How would we describe the effect? Well, if we subtract the perimeters, we get about a difference of 16 feet. For area, compare the areas. It looks like it's 1/3. So 60 is 3 times the length of, or the area of the 20, the measure of the 20. So after the change, it got smaller, in fact, by 1/3. So in summary, multiplying the length by 1/3 decreases the perimeter by, like we said, 16 feet. That's their difference. And decreases the area by a factor of 1/3. So in both of these examples, we can see that the scale factor for area was the same as the scale factor for changing a single dimension. So now let's take a look at changing 2 dimensions in different ways, which is what makes it non-proportionally changing dimensions. So if I double the length and triple the width, so I have different scale factors for each dimension, that's what makes it non-proportional. We want to figure out the effects on the perimeter and the area. So before the change, go ahead and do all your calculations. So with a length of 7 and a width of 6, we get a perimeter of 26 meters. This is a rectangle. So we're using our rectangle formula. You can look at your formula chart for all these formulas. Then your area is length times width, just like the previous rectangle. So 7 times 6, so 42 square meters. So let's see what happens after the change. So we're tripling the length, so now it's 14. Sorry, doubling the length, so now it's 14. Tripling the width, which is now 18. So plug in your numbers to get your perimeter, 64 meters. Plugging in our numbers to get our area. Wow. Okay, so 26 compared to 64, so if we're comparing the perimeter, what's that difference? Looks like it's a difference of 38. And then divide the original into the new area, or divide new area by the original area, and it's about 6. So doubling the length, tripling the width, increases the perimeter by about 38 meters, and increases the area by a factor of 6. Well, let's think about those numbers. I doubled the length and tripled the width. What value is that when I multiply? 6. So there is a connection between how I increase my dimensions and my scale factor on area. Okay, let's take a look at one more example. We've got multiplying the base by 1/2 and doubling the height. So do our calculations for perimeter and area. Anytime you're dealing with a right triangle, you're always dealing with Pythagorean theorem for that third side. This also is 6 and 8 are values for Pythagorean triple, so you might recognize that right away. So your hypotenuse is 10, but you can always use your Pythagorean theorem to confirm. So 36 plus 64 is 100, square root of 100 is 10. So add up all your sides, perimeter 24. Area, half of 6 times 8, 24 square inches. So let's see what happens when I multiply the base by 1/2 and double the height. So that gets us a base of 3, height of 16. Plug in, which means I have to do Pythagorean theorem again. I get an imperfect square root. Simplifying to square root of 265 plus the 19 in front. And then our height times base divided by 2 for the area comes out to be 24 square inches. And if you calculate the square root 265, it's approximately 16.279, and then add it to the 19. And that's where you get approximately 35.279 for the total perimeter. So compare that to the original, which is 24. So there's almost an 11-inch difference. And then compare your areas. And it looks like they're the same. So multiplying the base by 1/2 and doubling the height increases the perimeter by square root of 265 minus 5, or approximately 11.28 inches, and does not change the area. So why didn't the area change? Well, if I multiply the base by 1/2 and double the height, let's multiply those numbers together. So 1/2 times 2, doesn't that equal 1? So 1 doesn't affect any change. All right, let's hold on to that thought and move on. All right, so when change all dimensions of a figure proportionally, the resulting figure is similar to the original figure. So one of our core concepts is changing dimensions proportionally. When you multiply all the linear dimensions of a figure by a positive number we'll call k, then the perimeter and the area change as shown. Before multiplying all dimensions by k, you've got your perimeter, capital P, you've got your area, capital A. When I multiply all dimensions by k, the effect on the perimeter is the same factor, k, that I applied to all dimensions. But for area, I'm squaring that k value, meaning k times k again affects the area. So let's take a look at some examples. All right, describe how doubling all the linear dimension affects the perimeter and the area of the following parallelogram. So our parallelogram has a height of 4, a base of 10, and then the other length on the other side of the parallelogram is 5 meters. So for perimeter, we add up all the sides. There's 2 lengths of 10, 2 lengths of 5, just like we would do for a rectangle. We can double the length, double the width, and add up all that to get 30 meters. For the for the area, we just multiply base times height, just like on a rectangle. So 10 times 4. So make sure you multiply the correct numbers. Your height is from the base to the vertex, not this 5. This 5 is not your height. This has to be your height. It has to be perpendicular to the base. So we get a square, 40 square meters. So let's see how it affects when we double both dimensions proportionally. So we have now a base of 20, height of 8. Remember, k is our scale factor, so our scale factor is 2. We're doubling the dimensions. So that means it has the exact same effect on the perimeter as it does on each dimension, meaning we're going to double. So we're going to double that perimeter to be 60. So what's the effect on area? Our area has to get squared. So we square the scale factor 2, resulting in 4. So 4 times 40 is how we get our new area, 160 square meters. So doubling all the linear dimensions of the parallelogram doubles the perimeter and increases the area by a factor of 4. All right, that's all for effects of changing dimensions, and we'll practice these skills in class tomorrow. See you then.